Hello and welcome back to the TauNet team update for the month of November. You hear me follow, and without further ado, let's get into your Q&A questions for the month. Okay. And the first question is from Learn Tau, and he asks, what measurable performance or utility benchmarks must testnet achieve to proceed confidently to mainnet, ensuring the Agora's knowledge economy scales for contributors?
It's early to speak about the precise numbers, but aside from standard blockchain measurements such as throughput, so of course we aim at hundreds transactions per second, and latency and liveness. So we need to ensure that the blockchain stays alive for a prolonged amount of time, and we must have dozens of nodes across the whole world, decentralized, and we need to make sure that all synchronization, block propagation, other operations within the blockchain are fast enough of mainnet. Of course, we need to ensure that the security has no breaches and no issues. And regarding to Tau specifically, we need to ensure that rules, validation, execution are fast and reliable enough. As I said, it's too early to speak about precise numbers, but the direction is clear here. Thank you.
All right, fantastic. Thanks, Andre. And the next question is from Learn Tau, and they ask, hi, Ahad, is the laws of changing the laws, the legislation or governance level? Then next step is pointwise revision, being the execution or implementation level.
Yes, so pointwise revision is a way to admit the new law by passively removing contradictory parts from the old law. So yes, well, what you said sounds correct.
All right, fantastic. Thanks, Ahad. And the next question is again from Learn Tau, and he asks, when can we see the GitHub README of bit vectors and tables? Since it's a new base language of the Tau language, will it also be patented?
Thank you, Learn Tau, for that question. We have recently merged the implementation of bit vectors within the main branch of the TauLang GitHub repo, and including the README file. You should be able to go read it now and see the latest information on bit vectors. However, the tables feature is not implemented yet, so that's not there yet. With respect to the patent, will the Tau language be covered by some of the patents that we've recently obtained? Yes, absolutely, it will be. Thanks again for that great question.
All right, fantastic. Thanks, Kareem. And the next question is from Sam, and he asks, is there a GitHub repo for the testnet?
Thank you, Sam, for that great question. Yes, absolutely. There is, of course, a GitHub repo for testnet. It was private for a long time, but we've recently made it public, so you can go and take a look at that as well. Thanks again for the question.
All right, fantastic. And the next question is from Ethan, and he asks, what advantages does the Tau language have compared to the TLA+?
Okay, thank you for the question. So the first advantage of Tau is, and that is the whole reason around which Tau was crafted, and that is to speak about its own sentences. And what that means is that a Tau specification can specify properties about Tau specifications. So if you think about a program that receives an update, we in the Tau language can specify what this update basically has to satisfy in order for it to be merged into the program. That's something LTA Plus can't do due to language limitations, because some kind of self-referential mechanism that's needed for this in a controlled way is not part of the TLA Plus specification language. Then the second advantage of the Tau language is that it is decidable. LTLA plus is highly undecidable since it's based on the first order theory of set theory. And therefore, within the Tau language, we have much more room for more efficient algorithm to achieve whichever calculations are needed. That brings me to the next or the last point, that Tau is built with program synthesis in mind. Well, so what that means is that if you write a Tau specification, the goal of the Tau language framework is to make this runnable on the spot so that you do not need to implement any code. Just having the specification is enough to run the computer program. That's the goal. The goal of TLA plus, on the other hand, is to craft a specification and prove that that specification is realizable, so that it doesn't have contradictions during any execution path. And for these proof, basically, there are tools available like a model checker and a proof system. However, what you have in the end is just the specification that you proved correct in whichever sense, but you do not have the program yet. So you need to implement the program based on the TLA plus specification, and Tau aims to skip exactly that step. So that's in a nutshell what the advantages of Tau are compared to TLA plus.
I will add to that, to the point about specification versus synthesis, that it is not only a very nice to have to get the program automatically from the specification and advance the software development world many steps ahead by that, but it is also absolutely necessary for software to be controlled by its users. So the users say properties of software that the software should admit, and for the software to just become like this, instead of manually implementing those changes, you must have the synthesis ability.
All right, amazing. Thank you so much, guys. And the next question is from Learn Tau, and he asks, how can we improve and become better in writing rules in Tau?
Okay, thank you for the question. So in order to become better at writing Tau specifications, I think it comes all down to practice. And now that the bit vector implementation is there and we have introduced numbers in the Tau language engine, examples become more concrete. So now you can play basically with numbers. So that should help thinking about easy programs that you want to implement. And the general strategy for learning a programming language is really think about a simple thing that you want to implement and then just try to do it. And whenever you encounter problems, you need to think and ask perhaps questions on how to overcome this. And over time, it will lead to the ability to write specifications on your own.
All right. Thank you so much, Luca. And the next question is from Ethan, and he asks, on the TauNet, can the smart contract code of a DAO be amended by its token holders through group discussion, allowing for building a fully decentralized DAO? Yes, that is possible. And actually on Tau, you don't even need to use the token to be able to control the DAO functionality. So users will be able to use group discussion, and the system will be able to logically detect the opinion map and consensus and effectively control the DAO in whatever way they want. So the users can create the rules of how the DAO should function, and that might include the use of tokens, but it doesn't necessarily need to have that token requirement. And the next question is from Cryptid, and they ask, what makes Tau the only viable path toward a scalable, machine-readable knowledge economy? And why hasn't anyone else cracked it?
So the key is that you need a machine to be able to reason about knowledge and do certain operations with it. As everyone feels now, LLMs cannot do it. I was saying it since the beginning, but now it's becoming apparent to everyone. and the world of AI starts to realize that they need to use logical AI in order to support this. Again, as I said, for many years already, but they are still not aware of all the problems with a logical AI. So those technologies are just not mature enough. They are not working very well. So we made huge theoretical and technological advancement in the field of logical AI in order to bring it to a situation where it can do such things.
Fantastic. Thank you, Ahad. And the next question is from David, and he asks, when can we see a live example of Tau understanding, modifying, and validating real code or rules written by users, not developers?
So you ask about rules written by users and not developers, and from what I understand, you mean rules written in natural language. We will try to make LLMs translate from natural language to a formal language. It's not our current effort because we are so busy in releasing testnet and then mainnet, but it will come, and then it will help users to write in natural language.
All right, fantastic. Thanks, Ahad. And the next question is from William, and they ask, what prevents OpenAI, Google, or Anthropic from doing what Tau is building? For me, at least, I believe it comes down to three things. One, being the language. Obviously, Tau language is a very novel language, being decidable while being very deeply expressive and able to build a program that meets the specification. It is able to refer to sentences in the same language, which is extremely important for all the things that we've mentioned so far in the previous questions, such as pointwise revision and laws of changing the laws, and modifying code based on rules and requirements. So that's extremely important, but that is also protected by patents. So we have a patent on the Tau language as well. So that's the second part. And three is down to the team. We have a very, very unique team here. And of course, Google and Anthropic and OpenAI have very, very unique teams themselves. But we have a combination of mathematics, logic, computer science, and engineering that have come together to build extremely novel breakthroughs with Ahad and a backing from various professors, such as Professor Franconi. So I think that all comes together, and that's why we are so, one, ahead, but also protected by patents as well, putting us in a very, very good position to be placed very differently to Google, Anthropic, and OpenAI too. So the next question is from Learn Tau, and they ask, if a Tau spec has a universal quantifier, always the statement must hold at all time points, T. This Tau spec has a behavior over an infinite timeline. Am I right?
Yeah, thank you for the question. In short, yes, this is correct. Thank you.
And the next question is from Ty, and they ask, Tahad, have you spent time visualizing how we should bridge tokens to TauNet? And can a mere discussion about it automate the creation of this infrastructure?
Yes, this can be handled by a layer that we call the extra logical API, which Andre already started implementing for the purpose of TauNet itself. But yes, extensions of the extra logical API will allow bridging with other blockchains.
All right, awesome. And the last question is from Learn Tau, and they ask, can we run multiple Tau specs simultaneously on the TauNet testnet alpha?
Of course, we will run multiple Tau specifications simultaneously, but at this current point of development for Tau testnet alpha, we will run one instance of Tau asynchronously, and of course, if we see that there is a significant bottleneck, we will have to run multiple instances. Thanks.
All right, that about wraps it up for the Q&A questions for November. Thank you so much for tuning in, and thank you so much for your questions. Don't forget to join us on Telegram. That's TauNet, all one word, just TauNet. And on Twitter, it's Tau_net. And on Reddit, That is TauNet Agrs. That's TauNet Agrs. Do follow us. You could be in with a chance to win some Agoras and be early to the latest releases. Cheers.